And if you are ready, you may start.
Okay. Hi, everybody. My name is Raena Damaris, and thank you for attending my presentation about the Waterkeeper Alliance's Coal Ash Pilot Project. Waterkeeper Alliance is a global nonprofit fighting for drinkable, fishable, swimmable water everywhere. In the United States, one of the biggest threats to clean water is coal ash, a toxic waste byproduct of dirty fossil fuel energy generated in coal-fired power plants. Coal ash has demonstrated harmful and even deadly effects to human and environmental health. This project incorporated WebGIS, coding and automation, remote sensing and raster processing, vector analysis, cartography and visualization, and employs open source data sets. The project had 3 goals. The first goal was to develop an ArcGIS Online or AGOL tools to aid waterkeepers in identifying coal ash concerns in their jurisdictions. Now, although Waterkeeper is a global organization, this project was limited to the United States. The second goal was to develop a model builder model that processes Landsat satellite analysis ready data for surface temperature derived from thermal infrared remote sensing and prepares it for analysis. According to research, stream temperatures are rising, posing threats to biodiversity and contributing to harmful algae blooms. Some research suggests that coal ash is a contributing factor. The third goal was to conduct a preliminary bivariate correlation analysis between water surface temperature and proximity to coal ash waste to determine whether a significant correlation exists. A significant correlation would indicate that further research and analysis are worthwhile. To meet the first goal, a series of ArcGIS online web maps and app were created. The Global Power Plants database and open source dataset was used to create a web layer of coal-fired power plants. This map shows coal-fired power plants according to whether coal is the primary, secondary, or tertiary fuel source, and according to the plant's capacity in megawatts. Custom pop-ups were created using arcade programming language expressions and HTML coding that tie the pop-up colors to their symbols in the map, as you can see in the pop-ups here. The pop-ups contain information about the plant's commissioning date, its capacity, its fuel sources, and historical outputs. Another web layer uses coal ash waste data, which is another open source data set. This layer displays coal ash waste symbolized in a number of ways, including as the top 10 most contaminated sites in the US, coal ash waste by closure status, coal ash waste site by hazard rating, or coal ash waste by hazard rating and total volume of waste as graduated symbols, as you can see here. Again, pop-ups were created using arcade programming language expressions and HTML coding that create conditional attribute displays. For example, if a coal ash site does not overlap a waterkeeper jurisdiction, or if a coal ash site is not within 3 to 5 miles of at-risk communities, that information is omitted from the pop-up. Conditional displays also control the colors in the pop-up, which are tied to colors of the map symbols. A dashboard-style web app was created using the GUI version of Web Experience Builder and was configured for waterkeepers to use. The app allows waterkeepers to click on a jurisdiction, which triggers selection of all coal ash waste sites within that jurisdiction. The metrics on the left-hand side of the app update to display information about the selected coal ash waste sites, and the attribute table at the bottom of the app also displays attributes of the selected coal ash waste sites within the selected waterkeeper jurisdiction. The attribute table is exportable as a CSV and in other data formats. So to meet the second goal, a 4-part model was created using Model Builder in ArcGIS Pro that processes Landsat 7 and Landsat 8 analysis-ready data bundles for surface temperature. The data are at a 30-meter pixel resolution. The model was applied to a pilot study area encompassing Missouri and Kentucky, shown here in a crimson outline. Since distance is a factor in the analysis, an equidistant projection was used for all geoprocessing tasks. In the first part of the model, a mask of high-quality water pixels was created using a quality pixel band from each data bundle. High-quality pixels are pixels that have minimal or no cloud cover. The quality bands were copied to a Scratch folder using an iterator and wildcards that distinguish the quality pixel band from the other bands in the data bundle. Inline variable substitution copied the name of each file to the Scratch folder. And at this point, wildcards and raster iterators were used to distinguish between Landsat 7 and Landsat 8 data, which were processed separately. The quality pixel rasters were mosaicked together using the collect values tool, and then they were reclassified to a mask of high quality water pixels using a remap value table, like this one here that was used for Landsat 8. In the second model group, digital numbers in the surface temperature bands were converted to Kelvin and then degrees Celsius. Surface temperature rasters were again copied to the Scratch folder using a raster iterator with wildcards, and then they were mosaicked together again using the collect values tool. And the temperatures were converted to degrees Kelvin and then Celsius using a raster calculator. In this conversion, each pixel's digital number used the multiplicative factor and added offset from the metadata, as well as the coefficient to convert degrees Kelvin to degrees Celsius. In the third model group at the left-hand half of the slide, the converted Celsius temperature rasters created in the second group were subjected to the mask created in the first group. So as you can see here, there's a temperature raster in degrees Celsius, and the middle image is a mask of the high quality water pixels of that same area with minimal or no cloud cover. And when the mask is applied to the temperature raster, the output is another temperature raster, but this time it only contains high quality water pixels. So Landsat 7 data were processed independently of Landsat 8 data, and then the two extracted high quality temperature data sets were mosaicked together to create the final high quality water pixel raster in degrees Celsius. The final part of the model at the right half of the slide converts raster pixels to vector points as centroids using the raster to point tool. And then it adds the distance to each coal ash waste, to the nearest coal ash waste site, to each pixel in meters using the near tool, and that's as an attribute of the vector data. And then local bivariate relationships is conducted to determine whether there's a correlation between stream surface temperature and distance to coal ash waste in meters. To meet the final project goal of determining whether surface temperature is related to coal ash proximity, the bivariate correlation analysis was run 8 times. At first, no geostatistically significant relationship was evident. However, model parameters were altered to increase the local bivariate neighborhoods and permutations. And by the 5th test, which used a neighborhood of 200 and 199 permutations, over 90% of the data were significantly correlated. By the 8th test, which used a neighborhood of 300 and 499 permutations, over 94% of the data were significantly correlated, and the p-value indicates that there's a less than 3% chance that this pattern of data is the result of random processes. The data contain nearly 3 million data points, so output of a feature class failed on the 8th test because it was too much for my computer to handle. But the results of the 7th test are similar. It uses a neighborhood of 300 and 199 permutations. And again, 94% of the data are significantly correlated. And again, there's about a 4% chance that this pattern is the result of random processes, as you can see here in this pie chart showing the results of test 7. So in all 8 tests, there were more negative linear relationships than positive. That is, as temperature increased, distance to coal ash decreased. Another point to note is that as neighborhoods increased with each subsequent test, the number of undefined complex relationships also increased. It's worth pointing out that convex and concave relationships are visually similar to negative linear relationships in many of the bivariate tools scatter plot pop-ups in ArcGIS Pro. The x-axis in these plots relates to distance to coal ash, and the y-axis relates to surface temperature. So in all three of these scatter plot pop-ups in negative linear, convex, and concave, we see the same pattern that as temperature increases, distance to coal ash decreases. A final ArcGIS online web app was created showing the results of test 7. The app uses bookmark navigation at the top right side of the app to move around to different coal ash waste site vicinities. The bivariate results were clipped to within 2 miles of coal ash waste sites to save space in ArcGIS Online. There are buttons at the top left of the app that link to information about what local bivariate relationship analysis is and how it works. And there's another button that shows an image summary of all coal ash waste sites in the pilot study area. And then a spatial query widget was added that allows the user to explore the results of the bivariate analysis by clicking on the map and, if desired, specifying a search distance like 250 meters here. And when that is applied, a scatter plot widget in the lower left corner displays the results of the selected bivariate analysis data. Again, temperature is on the y-axis and distance to coal ash is on the x-axis. And you can see roughly a negative linear relationship here. The results of each point are also shown as an attribute table in the query results itself. So one of the major shortcomings of this analysis is that temperature data were not validated, although several studies indicate that Landsat surface temperature data is reliable to plus or minus 2 degrees Celsius. USGS stream thermographs or Waterkeeper Alliance water quality sampling data could be used to this end in the future. Another problem with this analysis is that coal ash waste data are points rather than polygons, and many are co-located. For example, at this Dominion power plant on the Potomac River, there are 5 coal ash disposal sites shown here as polygons, but in the available data that I used for this analysis, these polygons are points, and all 5 of these points are in the exact same location. So this obviously would affect the proximity analysis and the bivariate results. The study did not account for effluent discharge locations or cooling intake structures, and it was also unidimensional, considering only a single layer of Landsat data spanning from August to November of 2020. So ideally, a longitudinal or multidimensional analysis would be used in the future. It would be interesting to consider the difference between temperatures upstream versus temperatures downstream of coal ash waste, and to account for factors like coal ash waste site closure status, total waste site volumes, seasonal effects on temperature, water turbidity, water velocity, water depth, etc. Nonetheless, the results of the analysis suggest that a future study accounting for some or all of these factors would be worthwhile. For this project, I created a series of ArcGIS online web maps and apps to aid waterkeepers in identifying coal ash concerns in their jurisdictions. I created a reusable model for processing Landsat surface temperature data and using it in a bivariate correlation analysis. Now, we know that coal-fired power plants contribute to rising stream temperatures. Under certain conditions, these utilities are required to apply for thermal variance permits for effluent discharges into the rivers. Research also shows that coal ash waste has demonstrated heat production in landfills. What is unclear is whether coal ash itself, rather than the effluent discharge and related structures, contributes to elevated stream temperatures. To meet the final goal of this project, I tinkered with the bivariate correlation tool analysis parameters enough times to demonstrate a geostatistically significant and non-random relationship between water surface temperature and coal ash waste, indicating that future study could help clarify this complex relationship between the two variables. If you would like to explore the web maps and apps used in this presentation, they've been added to the portfolio style app that I displayed earlier, and you can click on the link to access that or point your device's camera at the QR code on the screen. Thank you so much for attending my presentation, and I will do my best to answer any questions that you have.